as the identity of conjunction. Kind of like, do we know the concept of identity values in mathematics? Okay. 0 is the identity of addition, and 1 is the identity of multiplication and also division. Okay. So, but in this case, let me show you why we know it is, an identity. So the way to do this with most Boolean algebra thing, we can just, enumerate all the possible cases. True is a variable; it is independent from y, and y is another, variable. So in this case, they both can be true at the same time, and the result is going to be true. X can remain true while y is false. This is false. X can be false, y can be true. The result is false. Both of them are false, and then the result is false. Is that okay? Does everybody understand that table? Okay, it looks kind of awful because I'm not using a spreadsheet to do it, but it is a table. It has 3 columns. 1 column for x, 1 column for y, and 1 column for the result of x and y. Okay, it's called a truth table. Why is that helpful? Well, let's take a look at the case. The first 2 rows are particularly helpful. If you take a look at these 2 rows here, do you see a pattern between the column y and the column x and y? You see a pattern. What is the pattern?
The same, right?
They are the same. Okay, they are identical. In other words, if I have true and something, I get that something back as the result of the conjunction. Just like when you multiply 1 to anything, you get that something back. 1 times x is x. 1 times 5 is 5. Okay, it's the same thing here. So that's why this is what allows me to perform this simplification. True and whatever is just that whatever. I can simplify it. Is that okay so far? Why we can do this one simplification? Now the simplification can work the other way too. So if you have something and true, it is also just that something. Just like with multiplication, x times 1 is still x. Because that has to do with conjunction, just like multiplication is, how do you call that in algebra? Commutative. Okay, it's commutative, which means you can switch the order of the operands, the 2 numbers, and it doesn't change the result of the operation. Division, on the other hand, is not commutative. X divided by y does not necessarily have the same result as y divided by x. Right, so good stuff. So now that we have post 1, we can work on pre 2. Okay. So in this case, I would say pre 2 equals to post 1 because these statements are sequential. Spelling out the obvious. Yep. Because line 2 follows line 1 in this case, there are no conditional statement, there's no possibility for me to go from line 1 to some other line instead of line 2. So they're sequential. I just want to make that clear so that we can establish what is pre-2 to begin with. All right, so then now that we know what is pre-2, let's just spell it out. So pre-2 is just that x equals to 2. Let's work on post 2. Now with post 2, I can reapply the same reasoning. In other words, the right-hand side of line 2 does not mention anything about the left-hand side. The right-hand side of line 2 has x in it, but it has nothing related to y. So because of that reason, we can use the forget rule. We have to use the forget rule. So in this case, we'll say post 2 is based on pre 2, but we have to forget something. So this is pre 2 here. We have to forget things that contain which variable, x or y. We have to forget things that contains y because y is the one that is being changed, not x. And after line 2, we know that x equals to y because it's an assignment statement. So that's why we know after that, y has to be the same as x. Now this is also one place where I have to re-emphasize or This is the first time here, so I have to emphasize, don't do anything like that, okay? The left arrow specifies an assignment operation. It is not an expression. It doesn't give you a result of true or false. It is saying, oh, we'll copy x to y, but it doesn't tell you anything that is either true or false. When you're specifying something in an expression, you need something that will give you a result of true or false. So that's why you have to use the equal symbol here and not the assignment operator. Next thing we do is we will spell out what is pre2. Pre2 says x equals 2. And then we actually apply the forget operation. Is there anything to forget here? Does anything mention y? Nothing, right? Nothing mentions y, so that means that there's nothing to forget. I get to keep the entire thing. So now we have this statement left. Okay. So what I'll do at this point is I'm going to branch in two different ways. One way is to go one step further and make sure that we conclude that y equals 2 and not just equal to x. Then the other way, we'll just leave it like this. Okay? So we'll do it two different ways, and I'll just label it. Okay, so I'll just call this result 1, and then we'll call the other one result 2, which is just taking this one more step and say, hey, since we know x equals 2 and y equals x, so that means I also know something about y equals to 2. So we'll just call this result 2. Are there any questions about this step, why we can go from result 1 to result 2? Is that okay? No questions about that? Okay. All right. So now we have to branch out the derivation. So we'll just go ahead and say from result 1, not going that one step to make y equals 2. We'll go ahead and try to work on post 3. Now line 3 looks like this, and we can reapply the same reasoning. The right-hand side of line 3 does not refer to the left-hand side, So we'll go ahead and just do that. So we'll say, well, first of all, we have to say pre3 equals post 2, because these statements are sequential. Okay. And then the next step, we have to say the right-hand side of line 3 does not refer to the left-hand side. Apply the forget rule. All right. So for the most part, I'm just really retyping a lot of the stuff that we have been dealing with. Post 3 equals forget pre3. Oh, forgot about this one here because I have to spell it out, which is x equals 2 and y equals 2. Oh, I was using result 1, so I only be at that point. Okay, so what are we going to forget in this case? If you look at statement number 3, are we forgetting everything that we know about y, or are we forgetting everything that we know about x? About y, because we're changing y, we're not doing anything about x. So we'll go ahead and specify that. We're forgetting everything that we know about y. And then after that, y equals 5, because 5 is on the right-hand side of the assignment. Next step, very mechanical, right? Okay, so we're just going to take whatever pre3 is, copy and paste it. So this time I do have something to forget, don't I? Because within the conjunction, we have x equals 2, which doesn't have anything to do with y, but the other side says y equals x. So that's the one that I have to toss away because at this point, after this assignment, I don't know whether that will still be true or not. So the result of the forget operation is I can only keep this one, and then I can say y equals 5. It doesn't illustrate the point that I want to make. Because the other one would do the same thing. Okay, never mind.
Assign 5 to x instead of y.
Instead of saying forget pre3, can you just say forget post 2?
Technically, yes, but you have to relate your post 2 to pre3 first.
Okay.
Just because it's one line below that doesn't always mean it is a sequential operation. Yeah, go ahead.
I was just saying you could change it, the program, to replace x with 5 instead of y with 5.
Replace x with 5.
At the top. Because then it would have to forget both of them.
But it would still be the same thing. It would still forget the
Then
same
it
thing.
would remember that y equals 2 if you had x equals 5.
But it will still forget this one here. Oh, I see what you mean. Okay, let's do it that way. So change this one to x. Oh, right. Okay, I see it. Okay, good. So we're changing that. Sorry about this. So I'm going to have to change this one to x, this one to x, because that really does illustrate, the point that I was trying to make. Okay, does everybody understand what I'm doing here? I'm changing the program so that on line 3, we are changing the value of x to 5 instead of y to 5. And it will illustrate a point in this case because I'm going to forget something. So let's see here. This is just x here. And the result here is still the same, almost the same, except this is going to be x. And what do we have left from the forget operation? If you look at the forget operation here, which part contains references to x? They both do. So I have nothing left from pre-3 that I can use because of the forget operation. Is that right?
Which means that post 3 you no longer know what the value of y is.
Sorry?
At that point, post 3, you no longer know what the value of y is.
According to this derivation, correct. Okay? So we only know that x equals to 5, but I'm saying that, well, at this point I don't know anything about y anymore because I have forgotten it. Even though this one could have been saved. Because if I carry that one step further earlier, then this particular comparison would not have any references to x. It would just refer to 2, and I could have kept it. So that means if I want to do this again, but from result 2, which is using this as the precondition of line 3, I would have saved, I would be able to save it. So I will say from result 2, okay, making y equal 2, then it would be the same, it would be different. So pre-3 still equals to post-2, blah, 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 the same reason. Except in this case, pre-3 is going to say x equals 2 and y equals 2. So you can see the important part here is this comparison mentions x. This comparison does not mention x anymore. So that really makes all the differences. The right-hand side of line 3 does not refer to the left-hand side. Apply the forget rule. So we are still doing the same thing here. So for the most part, this is really just copy and paste. I'm just retyping it. But the expansion of pre-3 is different because this time x equals 2 is still there, but the other one is y equals 2 instead of y equals x. And that really makes the difference because the forget operation now is saying, oh, okay, this one still contains a reference to x, we have to forget it. But this one does not. We can keep it. So once we keep it from the forget operation, the end result of post 3 is y equals 2 and x equals 5. So when you compare this conclusion versus this conclusion, the second conclusion from result 2 is more restrictive. It has more information in it. And that's the way we want it because the post condition, you can say, okay, what is a post condition of a statement? Oh, it's true, right? Well, as long as the statement is reachable, yes, that's something that you can say about the post condition. Does it really help you analyze the